Anyone who has taken a modern online course is familiar with a very specific kind of exhaustion. It is a persistent cognitive fatigue that has nothing to do with the difficulty of the subject matter. The root of this fatigue is structural. Most educational institutions treat their learning management system, the LMS, strictly as a static file repository. Instructors simply digitize physical classroom assets, uploading PDFs of syllabi and slide decks into folders. They are transferring files, not designing a digital experience. But in an online course, the digital interface cannot be a mere wrapper for content. The interface is the actual environment where all learning interactions take place. This diagram maps the multidimensional reality of the online learning experience. The center represents the learner, surrounded by cognitive, behavioral, emotional, and social dimensions. Notice the outer boundary. The course structure and interface enclose everything else, dictating the quality of every interaction inside it. To understand how to build this environment correctly, we have to reverse engineer this outer ring, starting from its abstract conceptual foundations and working all the way up to the visual surface layer. When the digital interface is fragmented and difficult to navigate, the learning process itself becomes fragmented. Fixing the interface is required to fix the pedagogy. All successful digital course architecture begins offline. Before any software is touched, the designer must define the foundational conceptual model based on the primary instructional goal. The first conceptual model is the knowledge domain course. Its primary goal is to acquaint learners with the core knowledge and vocabulary of a field. This model requires a topic-based architectural framework, where content is grouped logically around key theories, principles, and historical processes. The second type is the complex skill course. The objective is to teach learners how to perform complex, real-world skills. This model demands a task-based structural framework. Modules must mimic the sequence of real-world workflows, building from foundational subskills up to whole task integration. A common failure point occurs when a course description promises to teach practical, professional skills, but the content is mistakenly organized using a rigid, topic-based knowledge structure. The instructional goal must firmly dictate the structural framework. When the two are misaligned, learners experience immediate cognitive dissonance. Once the conceptual model is defined, it is translated into Layer 2, information architecture. This is the process of mapping the exact scope and sequence of the course content. Institutions often fall into an architectural trap provided by default LMS templates, the chronological semester week format. Organizing information entirely by dates reduces the learning experience to a disconnected checklist. It encourages rote memorization to meet arbitrary deadlines, rather than helping the learner grasp the relationships between concepts. Instead, designers must create a spatial mental model that groups content thematically. The most effective way to build this is by sketching low-fidelity prototypes, or wireframes. This hand-drawn wireframe illustrates the information architecture for a consumer finance course, translating a complex skill into a nonlinear digital map. The top left entry point groups foundational tasks, like basic cash management, into a starting phase. The navigational path communicates how these subskills build momentum, pulling the learner through wealth and risk management to the final goal. This hand-drawn map organizes the units entirely based on their relationship to the overarching task. Arbitrary calendar dates are completely absent. Drafting these wireframes first gives course creators the blueprint they need to break free from the linear constraints pushed by default LMS software. A strong information architecture allows learners to anticipate their exact journey and understand the context of their work before they ever read a syllabus. Information architecture handles the macro-level map of the course. Layer 3, information design, steps down to the micro-level of individual lesson pages. The default presentation style for academic material uploaded online is flat text. It is a dense, unstructured format commonly known as the wall of words. Flat text requires massive cognitive effort to parse. It overloads working memory, and as a result, learners frequently abandon the reading entirely. To solve this, instructional designers apply Robert Horn's method of structured writing. This document on meeting ground rules demonstrates how structured writing transforms dense paragraphs into highly scannable, blocked text. Explicit left column labeling immediately signals the function of the adjacent text. The reader knows what they are looking at before reading a sentence. Generous white space and bulleted lists break conceptual models into digestible pieces. This visual chunking directly increases reading compliance. By making the text visually approachable, the perceived cognitive effort drops. When information design is executed perfectly, it is largely invisible to the user. Learners simply note that the content makes sense and is easy to find. Designing information is not about decorating text. It's a strict mechanism for cognitive load reduction, ensuring the learner spends mental energy on the subject matter, not deciphering the page structure. The final layer sits directly on top of the architecture and formatting. This is visual design, the aesthetic surface of the digital environment. Academic environments frequently dismiss visual aesthetics as superficial, treating them as secondary to the rigorous core content. The data proves otherwise. Psychologist Daniel Kahneman's concept of System 1 thinking explains that humans process initial information involuntarily and automatically. Learners make instantaneous judgments about a course's credibility and value the second the page loads. This is the fully realized user interface built from the earlier consumer finance wireframe. The graphical treatment, presenting the modules as a continuous game board with clear phased groupings, instantly communicates the path metaphor directly to System 1 thinking. It feels intuitive immediately. In this fitness and wellness module, simple elegance and clean typography set a welcoming, organized tone for the academic content. Conversely, a chaotic visual layer featuring poor contrast, clashing fonts, and competing graphics will overwhelm the learner and completely bury the actual syllabus. Clean, elegant visual design is a pedagogical imperative. A positive first impression removes emotional friction and builds immediate trust in the instructor's authority. The digital learning environment is an engineered stack. It relies on a precise sequence of decisions, from conceptual foundations to the polished visual surface. Looking back at our core framework, we see how this structure serves the student. The outer ring, the course structure and interface, binds the entire experience together. It seamlessly supports the core human elements of learning: cognitive, behavioral, emotional, and social. The instructional goal dictates the architecture. The architecture shapes the information design, and visual aesthetics smooth the pathway. The ultimate hallmark of a successful digital course design is that the interface becomes virtually invisible to the user. Learners completely stop fighting the LMS software. They navigate intuitively, find resources effortlessly, and feel comfortable existing in the digital space. By applying rigorous UX principles to pedagogy, the learner's working memory is freed from technological frustration. They are finally permitted to direct all their attention exactly where it belongs, grappling with the subject matter itself.